All right, Chloe. Test 19. Let's knock this thing out. Number 1. Write negative 3r plus 3u in polar form. So let's make our graph so we can see it. All right, we've got negative 3r. So that's to the left, right? Negative 3 over here. That's 3 from 0. That's negative 3 right there. And then we have positive 3 up. So 1, 2, 3 up. So that's about right there. All right, so 3 up. So there's our right triangle, just like that. We don't know what the degree of measure is, right? So we have a 3 leg and a 3 leg on this right triangle. This is a right triangle right there. We know we use Pythagoras' theorem. 3 squared for this leg plus 3 squared for the second leg is equal to the hypotenuse squared, right? 9 plus 9 is 18. If we square both of those, that cancels. And we could say 2 times 3 is 6 times 3 is 18. So we got a pair of 3's. So that's going to be 3 times the square root of 2 is equal to c. So that's what that is. So our first part is going to be 3 times the square root of 2. Now we're ready for the degree of measure. We don't know what that is, so we're going to use the inverse tan. All right, so it's negative tan. That's the inverse tan of that degree of measure. We don't know, which we don't know. And tan is SOHCAHTOA, so OA, opposite over adjacent. That's going to equal 1. The inverse tan of 1 is 45. I'll show you that now. 1 inverse tan is 45. Boom. So 45 degrees, the tan of that is 45 degrees. So if this is 45 degrees here, we know that's half of 90, then that means this is 45 degrees here. So we start here, and we have 90 degrees there, and then we have 45 degrees there. 90 plus 45 is 135. So that's what we write over here, 135 degrees. That's the answer. And that's what we have right here. Okay? All right, let's do the next one. We have negative 5 squared over negative 27 to the negative 2 over 3. All right, first thing, we're going to bring this up, get rid of that negative sign on that negative 2. The denominator is always positive, so it doesn't affect the index on the bottom, just the exponent. This is the index, this is the exponent. So the index isn't bothered when we move it up or down, just the exponent, right? Okay, so when we do that, we go ahead and multiply. That'd be negative, we have 5 squared, so it'd be negative 25, and then we would have negative 27. That doesn't change, but now we have 2 over 3 as our exponent. But when we want to separate it out, we put an exponent of 1 there. We put the exponent on the outside. Okay, we always move the exponent to the outside whenever we convert it and bring it up to the numerator. And whenever we pull it out of a fraction, it looks like that. So now we have a negative times a negative, but I want to deal with this first. So this right here, if we have negative times negative, then this is going to be positive. It gets rid of the negative signs for us to go ahead and multiply both of these times that negative 1, and just erases them, right? So now this is actually this, right? That's exactly what that is. We know that that's going to equal 3, because 3 times 3 times 3 is 27. So now we have 25 times 3 squared. 3 squared is 9. 25 times 9 is equal to 225. Okay? That's the answer there. Got me? All right, moving on. Let's hustle through these. I want you to understand what you're doing, but I also want you to, do well. master this. So we have this degree of measure here, right? So we know that this degree of measure and this degree of measure are opposite angles. So they're going to equal the same thing. So the degree of measure we're looking for is this one right here. So we know that this one is going to be equal to this one minus this one divided by 2. So we've got to figure out what this one is. So we know all the way around is 360. So 360 minus 180, which is this one, minus 130 should equal this arc right here. So that's going to be 360 minus 310. That's 50 degrees. So 180 minus 50. 180 minus 50 divided by 2. That's going to be 130 divided by 2. That's going to be 65. So this is 65 degrees. That means X is 65 degrees because they're opposite of each other and they have the same degree of measure. So 65 is the answer. Okay? All right, let's look at this one. So we have 3 times the square root of 2 minus 4 over square root of 3 minus 2. We are going to rewrite that in the right order. So that's going to be 3 times the square root of, or I'm sorry, hello, write it the right way, Tracy. Negative 4 plus 3 times the square root of 2 over negative 2 plus the square root of 3. Now we are going to change the sign and conjugate. Right, so that is going to be, let me find it in here. Just want to make sure that I am doing all of the steps the way that, the right way. I don't want to mess up. And I cannot find it. How come I can never find it in this book? I wonder if I got it from, oh no, I found it. Here it is. So yeah. So we are going to conjugate this. And that is not what they did. So anyway, we're supposed to change the signs. We're going to change the sign. So times negative 2 minus the square root of 3. Negative 2 minus the square root of 3. So that's going to be hello. It's a 2. Negative 2 minus square root of 3. So that's going to be a negative 3 times the square root of 6 and a positive 4 times the square root of 3 and a negative 6 times the square root of 2 and a positive 8. All right, we got a bunch of different ones right here, don't we? All right, so I'm going to rewrite that. Let me see if, yeah, that looks about right. 8 minus 6 times the square root of 2 plus 4 times the square root of 3 minus 3 times the square root of 6. All right, that's everything in one statement. So there's our numerator. So now I'm going to do our denominator. So the denominator is negative 2 plus square root of 3 times negative 2 minus square root of 3. That's going to be negative 3. And then I have a 2 times the square root of 3 positive, negative 2 times the square root of 3. they cancel each other out. Negative 2 times negative 2 is a positive 4. So that gives me 4 minus 3, which equals 1, right? So 4 minus 3. So that's all of this over 1. Anything over 1 is a whole number. So the answer is just 8 minus 6 times the square root of 2 plus 4 times the square root of 3 minus 3 times the square root of 6. So that's your final answer. Alrighty then. That was number 4. You got number 5 correct, all by yourself. Let's look at number 6 and clear the page. So we have 3i plus 2 times 2i minus 3. If you hear a bunch of racket in the background, they're pouring concrete at my house. You were here just the other day, so you saw where they were forming everything up. So that's the racket. If you hear a bunch of beeping and stuff backing up and all that craziness. Okay. I don't know why I wrote the number down. It's kind of silly. 3i times 2i, 6i squared. 3i times negative 3, negative 9i. 2 times 2i plus 4i. 2 times negative 3 is minus 6. So that's done, right? So we take the negative out of here, so we have negative 16i, and then I squared is a negative 1. Negative 2 times negative 1 is a positive 2. And then we have plus negative 1i, because I squared is negative 1. So now we're going to solve this one. That's going to be a 4, negative 4i. So let's put, this is going to be a negative 1 because I squared is negative 1. So 6 times negative 1 is negative 6. And then we have minus 9i plus 4i minus 6 minus 4i plus 2 minus 1i. Okay, so let's do all the whole numbers. Negative 6 and negative 6 is a negative 12. Plus 2, that's a negative 10. All right, I have negative 9 plus 4. That's a negative 5. Minus 4, that's a negative 9. And basically, these two are just canceling each other out. So negative 9, negative 1, that's a negative 10i, which is what we have here. Negative 10 and a negative 10i. All right, number 7, we have negative 2, then we have 4, and then we have 2. Okay, and we have to put it into the thing. So we start with the innermost, and we have the square root of 2, and that's going to be, we need the index and the integer, so it's 2 and 1/2, right? And then we have the square root of 4, that's going to be 2, so that's going to be times 2. And then we have negative 2. Just like that. I think that's right. Actually, this 2 is squared, and then it has the 1/2 on the outside. Is that right? Yes, because we have to do that because we have to include the fact that this square root is over this square root. So we have to put the index of this, which is 2, here, over this one, which is right here. Let me go backwards through that again so you can see what I'm talking about instead of adding it after the fact. So we start with this one. That's going to be 2, and put it in parentheses. 1/2 goes on the outside. Sorry, I always like to put them on the inside. It's pretty close to the same thing, but it's fine. So now we have 4 inside of a square root. So that 4 is going to be 2 squared. We're putting that, it's under a square root symbol, and so this is the index or the exponent for a square root. It's 1/2. And so then we have the -2 times all of that. So -2 is on the outside. So now we can solve by multiplying. So when we have -2, let's just leave that alone for now. 1/2 times 2 is going to be 2 over 2, so that's 1. So we just have a 2 here now. And this is going to be 2 and 1/4. If my thing will right. All right, so this would on pen. My pen won't start. There we go. So we multiplied the 1/2 times the 2, and we still have the 1/2 on the outside to do this, right? Of this one right here. So we already did this one times this, and this one times this, and that gave us 2 over 2, so that's just 2 by itself. 2 to the 1 is just 2. And then we did 2 times 1/2, so that's 2 1/2. Now we still have the 1/2 from the original one that we did. So that's going to be 1 times 1 and 2 times 2, that's 2 and 1/4. So 2 times 2 times 2 and 1/4. Well, we know whenever we have, it's -2, whenever we have a whole number here, we're just going to change this exponent to match the value of this fraction. So that's 4 over 4, right? And then that'd be 4 over 4, because it's 2 to the 1 and 2 to the 1. And we know when we multiply, we add exponents. So we've got -2 times 2. It's going to be -4. -4 times 2 is -8. And then that's 489 over 4. How was it? Oh, ignore me. It's -2. It's the same base, so we don't actually multiply it. Sorry. We leave the base alone and we just add the exponents. Just like if this were x and 4 over 4 and x and 4 over 4 times x and 1/4, then it would just be x and 9 over 4. That's what you have to remind yourself of whenever you're doing these. You don't actually calculate the 2's. They're just x's. They're just a variable, basically. So that's what I did wrong. It should be -2 and 9 over 4. -2, 9 over 4. Okay? While we changed this 4 to 2 squared so they'd all be the same base. That's why we did that. All right. Number 8. I don't particularly care for those types of problems because they can be very confusing. Those are some of my least favorite to do. So see, even math nerds have less favorite problems. So here's another one. Oops, and I started out wrong already. A cubed, x to the 0, y squared, a to the 1/2, x to the 3rd, and then y. And my little line is not quite all the way long enough. All right, I'm going to have to follow the book on this one because that one's very confusing. Okay, not so bad. All right, this x goes away entirely, right? Because it's x to the 0, so it means it's just 1. So we can ignore it. It's always nice when we can eliminate something from the problem. So what we have to do is we have to take each one of these and give them an index on the outside of this. So the first thing we're going to do is we're going to look at, let's look at the a's because there's more than one of those and we need to combine them. So this a would, let me redo this. This a, we're going to rewrite that index there. Since this has got a base of 2, we're going to rewrite that with a base of 2. So that's going to be 6 over 2. A and 6 over 2, and then a and 1 over 2. And then we have y to the 2 x to the 3, and then y. So now let's look at our y's. We actually have 3 y's. So why not go ahead and just change this to a 3? Now it's simplified. And now if we look at our a's again, we have 6 over 2 and 1 over 2. We can change that to 7 over 2 and get rid of the extra a, all right? So now we have that underneath, and that's all we have. So now we're going to rewrite those with an index of the square root around it. So a and 7 over 2, y cubed, x cubed, and then this takes the place of the radical sign, this right here. And now we just multiply. So this would be a and 7 over 4, y 3 over 2, x 3 over 2. And that would be our answer, which is what that is. Okay, find C. So x k equals p 1 cm1 minus 1 m2. And these are not, if I remember right, these are not the same m. These are two different types of m. They're subscriptive variables that represent different, either a different point in time or just something different. So what we're going to do is we're going to multiply first, get rid of this distribution. So xk is equal to p over cm1 minus p over m2. All right, now we're going to find common denominator, which means we're going to multiply cm1 m2 times everything, right? So I need to multiply m2 times this one. Or actually, let's just go ahead and multiply this times everything over here. So cm1 m2 times x times k is equal to m2 times this, allows me to get rid of this. So p m2 minus, and this one times that, is going to be pcm1. And we're solving for c. So I want to get PCM1 over here. So I'm going to add that to both sides. So CM1 M2 XK plus PCM1 equals PM2. All right, factor out the C. M1, M2, XK plus PM1 equals PM2. Now you know the drill. We're just going to take this, we're going to divide by this factor, M1, M2, XK plus PM1 equals, divide on both sides, M1, M2, XK plus PM1. So now that these two have canceled out, C is equal to PM2 over M1, M2, XK plus PM1. And that is the answer that I have here. I just have it in reverse order, PM1 plus M1, M2. So when you type it in, know that these are reversed. And you type it in the right order and it'll mark it right for you. All right, clear the page. Number 10, let's scooch this up a little bit more. Solve 2x squared plus 3 equals x by completing the square. 2x squared plus 3 equals x. All right, so we're going to subtract x from both sides. 2x squared minus x plus 3 equals 0. 2x squared minus x equals negative 3. Negative 1 divided by 2 equals a negative 1/2 times negative 1/2 is equal to positive 1/4. So plus 1/4 plus 1/4. All right. So now I can factor this, and that's going to be 2. Oh, I'm sorry. I do this all the time. Every time I do this wrong. You've got to get rid of the lead coefficient first. Divide everything by 2. So that's going to be x squared minus 1/2 x plus 3 over 2 equals 0. So now I can do the x squared minus 1/2 x, leave a little space, equals negative 3 over 2. Okay, negative 1/2. Divide that by 2, so I'm going to multiply it by 1/2. That's going to equal negative 1/4. Then I square that, and that's going to equal 1 over 16. That's what I add, 1/16 to both sides. All right. So now I can factor this by using the negative 1/4. So x minus 1/4 squared equals. And this is going to be, I need to multiply this by 8, so it's negative 24 plus 1, so it's negative 23 over 16. All right, so that's where we are now. Let me see. Two x squared, where am I at? There it is, I found it. All right, so good so far. I'm right so far. So now I get rid of this and I say x minus 1/4 is equal to the square root plus or minus 23 over 16, which we know we can get the square root of 16, right? So that's going to be plus or minus the square root of 23 over 4, because that is what it would be and when we square the 16. So we're going to add 1/4 to both sides. That's going to be equals 1/4 plus or minus the square root of 23 over 4, which is what we have here. And actually, I'm sorry, I dropped the negative, so that would become I right there. So don't drop that negative. It's important. It's the square root of negative 23 over 4 is the square root of 23 over 4i. Okay. All right. That was number 10. Let's look at number 11. So I'm not going to redraw this shape since we have it right here. We just have to find y. So that is it's in here somewhere. Here it is. All right, so I have x squared is my hypotenuse, and then I have that's equal to 7 squared plus 5 squared, right? You would probably are used to seeing it 7 squared plus 5 squared is equal to x squared, right? That's, we're finding x is what we're doing. So then that is going to be 49 plus 25 is equal to x squared. I square both of those. That's going to be 49 plus 25 is going to be 74. So the square root of 74 is equal to x, because those two cancel. Square root of 74 is going to be the value of x. All right, so now that I have that, I'm going to find the ratio here. So my ratio of x and y, it's going to be x plus y. I have this small one is 7, but then the long one is 12. So my ratio is 7 over 12. And if x is corresponding to the 7, then that's the square root of 74 goes on top. And then on the bottom, we have the y value plus the x value is square root of 74. And the reason we have that is because on the bottom we had the corresponding leg of 7 that goes with the x plus the corresponding leg of 5 that goes with the y. 7 plus 5 is 12. All right, and then we put the 7 over 12 to give us this part, and this is the x, and this is the x. That first little triangle, those are the dimensions that have something in common. All right, so now we just cross multiply and solve. So we have 7y plus 7 times the square root of 74 is equal to 12 times the square root of 74. So if I divide everything by 7, actually what I'm going to do is I'm going to not divide just yet. I'm going to subtract 7 times the square root of 74 from both sides. All this racket is kind of distracting. It's making it hard for me to stay on track. And that gives me 5 times the square root of 74. So y is equal to 5 times the square root of 74 over 7. And that is the answer we have right here for the length of y. All right. Let's see, number 12. Use the quadratic formula to solve. So much easier to use the quadratic formula. So we have 2x squared plus 3 equals negative 2x. That's going to be 2x squared plus 2x plus 3 equals 0. So that means A is equal to 2, B is equal to 2, and C is equal to 3. So now I can say x is equal to where did that go? Plus or minus, it is so stinking loud. Negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. That's the quadratic formula. So now I'm going to drop everything in. X is equal to, b is 2, so it's going to be negative 2 plus or minus, I'm sorry if it's really loud, sweetheart, it's annoying, I know. B squared is 4 minus 4 times 2 is 8, times 3 is 24. All over 2 times 2 is 4. So x is equal to negative 2 plus or minus the square root of negative 20 over 4. Alright, so let's do some things to this. this eraser. This will become, because it's a negative 20, square root of 20i. Okay, so this can be reduced to negative 1/2. Right, so negative 1, because I divided both of those by 2. So 2, and then I have to do it like that because this is an imaginary number, so we can't have them on the same fraction. But now 20 is going to be the square root of 4 times the square root of 5, so I can turn that into a 2, right? Am I doing this in the right order? No, I'm not. This should still be a 4 because I haven't reduced anything from here on this side. So, but now I can turn this into 2 times the square root of 5, and then I can reduce this to 1/2, which is just written like that. All right. So that would be your final answer. Negative 1/2 plus or minus the square root of 5i/2. But just type in this part. I don't ever type in x equals. That's kind of understood. Oh, I'm getting ready for afternoon nap. I don't know about you, but math makes me sleepy. Alright, Archimedes, you got the first part. Good job on that. Archimedes ran 3 times as fast as his challenger ran. So Archimedes, challenger. So his rate, Archimedes is 3 times the challenger, and then the challenger is just whatever he is. In fact, he ran 60 miles in 3 hours less. So there's Archimedes and the challenger. He ran 60 miles in 3 hours less than it took his challenger to run 32. Excuse me. This noise is driving me nuts. It's making it hard for me to think. So the challenger ran 32 miles. Alright, so the rate of Archimedes times the time of Archimedes was 60 miles. The rate of the challenger times the time of the challenger was 32 miles, right? And we know that the rate of Archimedes is 3 times the rate of the challenger. So if the time of Archimedes was 3 hours less, so the time of Archimedes, he ran 60 miles in 3 hours less than it took his challenger. So his time was 3 hours shorter than his challenger. So his the time of Archimedes is the time of the challenger minus 3 hours, because Archimedes was faster. Okay, now we can start dropping all this stuff in. So the rate of alright, here we go. The rate of Archimedes is 3 times RC. Okay, we're doing RATA equals 60. And the time of Archimedes is TC minus 3. So TC minus 3. That equals 60. All right, what I did was I took this formula and I dropped this value and this value in here. So that's going to be 3 RC TC minus 9 RC equals 60. How about that? Now we know that RCTC is 32. So 3 times 32 is going to be 96 minus 9 times RC is equal to 60. So if we subtract 96 from both sides, then negative 9 RC is equal to negative 36. Divide both sides by 9, RC is equal to 4. Right? Negative and negative. So the RC, the rate of the Challenger, is 4. And 3 times 4 is 12. So now we've got to find the time of both. So the time of the Challenger is 3 hours more than TA. Well, now that I know what the rate of Archimedes is, I know the rate of the Challenger is 4. I can say 4 times TC is equal to 32 because I know what the rate of the Challenger is. I dropped it in here. 32 divided by 4, TC is equal to 8. The time of the Challenger is 8. The time of Archimedes is 8 minus 3, so that's 5. Yeah, so I don't know why you had negative 4. It should have been positive 4 and positive 8. So you got really close. You did the right math, but you just put the negatives in. So just go back and take the negatives out of that. Okay? All right, number 14. Let's do it. So 2x plus 1 over x plus 4 plus 3x minus 2 over x plus 4, x minus 1. We just need to multiply the top and the bottom by x minus 1. Now that they have the same denominator, we can write it all together. So that's going to be in parentheses the whole thing. So that's going to be 2x squared minus 2x plus x minus 1 plus 3x minus 2 all over x plus 4 times x minus 1. So let's combine some things. All right, so that's going to be plus 3x, 4x minus 2. So that's going to be a positive 2x total. And then minus 1 minus 2 is going to be minus 3. So negative 2x squared plus 2x minus 3. I think that we can factor that into something. So if I said 2x times x, can I factor that at all? Or is that as far as I can go? No, I can't factor that. I'm looking at it and that 2x in the front is just going to make it hard to do anything with. So this is your final answer. 2x minus 3 all over 2x squared plus 2x minus 3 all over x plus 4 times x minus 1. That's your final answer. All right, number 15. Let me clear this. Estimate the location of the line indicated by the data points write the equation that gives magnesium as a function of calcium, and magnesium is equal to, it's just y equals mx plus b, but we're using something different for y and x. So it's going to be, we have these 2 points that I've specified from here and here, right? So it's actually this point here and this point here that I've called out, because those are the 2 places where they cross the line. So we're going to say magnesium equals the slope times calcium plus B. So really, really quickly, we're going to do the slope. So that's going to be 50 minus 450 over 30 minus 35 equals negative 400 over negative 5, which equals a positive 80. All right, so now we have mg is equal to 80 times ca plus b. Right? We're just doing the slope. That's what the slope is. It's the same thing we did here. We just have different letters here and here. Now we have to find the plus b. So all we have to do is substitute in the magnesium, which is the y, and the calcium, which is the x. So we're going to pick one of these points. Let's just pick this point right here, because then that's easy. So 50 is the y, equals 80 times 30, which is the x, plus b. So this is going to be 50 is equal to 24,000 plus b, right? And then we subtract 24,100, sorry, not 1,000, from both sides. And we get negative 2350 is equal to the b, because that canceled. So now we just put that back in. So mg is equal to 80 ca, and then because it's a negative sign, that's going to be minus 2350, just like this down here. mg equals 80 ca minus 2350. Number 16. Find x. Easy peasy. When it's inside the circle, it's just half of this. So 110 divided by 2 is equal to 55 degrees. Easy peasy. All right, you got number 17 right. You did 21.5. You could have just said 43 over 2 and left it, but you went ahead and divided, and that's fine. All right, 4 problems. So write the rectangular form. Let me erase that. Rectangular form of 3 and negative 60 degrees. So we're just going to do this right here. First, we find our negative 60 degrees. When it's negative 60, it starts here and goes this direction. So if it's going 60 degrees this way, then it stops. 90 minus 60 is going to be, this is 30, but it's always to the x-axis, so this is 60. All right? So 60 degrees that way. And now we need to figure out, we have 1.5 here, and we have down, we have, okay, 2.6. And we have the degree of measure, which is 60. So all we have to do now is use our Pythagorean's theorem to find oh, I'm sorry. You know what I did? I looked at my answer instead of using this to find the length. This is 3 right here. I'm going to try not to look at the answer, even though now I know what it is. Okay, so we have 60 degrees, and then we have this, right? So we use SOHCAHTOA. So the sign, so is SOH. So the sine of 60 degrees is going to be, this is going to be the opposite. This is the adjacent, and this is the hypotenuse. So opposite over, which is going to be, in this case, sorry, the opposite is going to be negative u, and this is going to be positive r. Because it's below the x-axis, it's in the negative y-axis area, so it's going to be a negative u. And then this is to the right of the y-axis, so it's in the positive integers, so it's a positive r. So negative u, and the hypotenuse is 3. So I find the sine of 60. I feel like we've done these a million times. 60, and I need sine of 60 is 0.87. So 0.87 is equal to negative u over 3. Multiply everything by 3. So I take this times 3. 2.598. I'm just going to round it up to 2.5 or 2.6. So 2.6, and it's negative u, negative 2.6 u, which it's below, so that's why. So we have negative 2.6 u. I put the decimal in the wrong spot. I am so sleepy. I guess it's the time of day. 2.6 u. And then now we do the same thing for r, only we use cosine. 60 equals r over 3. Multiply both sides by 3. Clear this out. 3, the cosine is 0.998. That's almost 1, right? I'm just going to write it like this. 3 times the cosine of 60 is equal to r. So I'm just going to take the cosine of 60 and multiply it times 3 as it is. 2.995. I don't know how I got 1.5. Did you just hear that click? That was my neck. Oh my goodness, I'm getting old. I'm looking in my book, double checking my answer, sweetheart. It says 3 times the cosine. Let me clear this off. 60 cosine. Okay, I didn't do something right. I didn't clear it out. That's why. Times 3 is 1.5. All right, so 1.5 equals r. So be sure whenever you do it on a calculator, make sure you clear it really good before you get started. So 1.5 r minus 2.6 u is your answer. Okay. All right, so yeah, I just didn't clear it out. That's why I didn't get the right answer before. And that's important. Make sure you don't have any other calculations hiding back there. All right, so we did that one. We're on 19 now. Find the equation of the line that passes through. We have 3, negative 1, and is perpendicular to the line that passes through. Negative 5, 2, and negative 1, 7. All right, so first we have to find the equation of this line and then find the perpendicular slope to that. Okay, so that's going to be 2 minus 7 over negative 5 plus 1, because that's a negative. Negative 5 over negative 4. Okay, so that's our slope. And now we have to find our plus b. So y is equal to negative 5 over 4. Actually, negative 5 and negative 4, that's going to be a positive. So that's going to be 5 over 4, turning it into a positive. X plus b, I'm just going to pick this first point because it's just the first point. 2 is equal to 5 over 4 times negative 5 plus b. 2 is equal to negative 25 over 4 plus b. I'm going to add 25 over 4 to both sides. All right, and I'm going to convert this into 8 over 4. So 8 over 4, because that would be the same thing as 2. 8 plus 25 is going to be 33. 33 over 4 is equal to b. So the line here is going to be y equals 5 over 4 x plus 33 over 4. All right, so we don't really care so much about that. We just need to find the perpendicular. So it's going to be the opposite sign and the inverted or the reciprocal fraction. So it's going to be y is equal to negative 4 over 5 x plus b. And we use this point to find our plus b. So negative 1 is equal to negative 4 over 5 times 3 plus b. Negative 1, that's going to be negative 12 over 5. That's going to be plus 12 over 5 plus 12 over 5, okay? So that's going to be negative 5 over 5, right? Because it's a negative 1. So that's going to be a positive 7 over 5 is equal to b when this cancels. And we do the math here. So now I can just put that in 7 over 5 for b. So this is the answer we're looking for. Would be y is equal to negative 45x plus 7 over 5. Negative 4 over 5x. All right, number 20. Let's clear the page. I have ax plus a over x minus x a. Common denominator. That's going to be xa minus x over a. All right, so we put that in. There'll be ax plus a over xa minus x over a. Keep it, change it, flip it. So a over 1 divided by turns to, we change that, and then we flip it to a over xa minus x. That's going to equal a squared over x a minus x. So ax plus a squared over xa minus x. Common denominator, that's going to be ax times xa minus x plus a squared all over xa minus x. So this is going to be a squared x squared minus ax squared plus a squared all over ax minus x. I need to put everything in alphabetical order to make it easy. And that's what I have here. All right, last one, sweetheart. 3 times the number of blue marbles, so 3 times the blue marbles, exceeds twice the number of red marbles by 18. So add 18, wait. 3 times the number of blue marbles exceeds twice the number of red marbles. So twice the number of red marbles plus 18. Also, 5 times the number of blue marbles is 2 less than 6 times the number of red marbles. Okay. How many of each are there? Looks to me like a elimination problem. So let's eliminate. Let's 3b minus 2r equals 18. And 5b minus 6r equals -2. So I just shifted, I subtracted the r's from both sides so it could be set up the way that we're used to it. All right, I'm going to multiply this one by -3, right? So that's going to be -9b plus 6r equals, what is, all right, I need my calculator because this is the last one and my brain's tired. All clear, all clear. 18 times 3, 54 is going to be -54. All right, now I can put them together. So -56, -4b. Divide both sides by 4. I get, or -4. I get b is equal to, divided by 14. Number of blue marbles is 14. So I'm going to substitute that back in up here to this first one. 3 times 14, carry 1, that's 42, is equal to 2r plus 18. Subtract 18 from both sides. 42 minus 18, 24. 24 is equal to 2r. It's doing, it's like it doesn't recognize. It's like it switches back and forth and it won't work. Come on. Last problem. 2r. So that means that 12 is equal to r. All right. So we had 14 blue marbles and 12 red marbles. Ta-da. We solved it. All right, sweet girl. That is test 19. Go back and do test 19. Bring your grade up. You are capable of all of this, and I know you understand it because we walk through it and you get it. You just get lost in all the details when you do it on your own. Write these down, and when you write them down, write out your steps that you're doing so that it makes sense to you. You need to write the steps in language that you understand what you're doing, because sometimes my words don't mean the same thing. Like I'll say it one way and it doesn't illustrate it for you the way that you need it said. Right? You say it the way that you need to say it when you take your notes. All right, sweetie, I'll see you Thursday. I don't know why this thing's not stopping. Come on, stop. There we go.